Hi everyone. I'm Ankit. I'm a software engineer at the real-time analytics team here at Uber, and I'm excited to share like some of the recent work that we have been doing with Presto regarding our use case. Just to give a brief overview of the platform before we get into the recent work. So the core technologies that we use for real-time analytics at Uber is Pino and Presto. So Pino essentially forms the core storage layer and the query engine, and Presto we use Presto to essentially proxy all the traffic for Pino. So users still get a Presto interface, and underlying that they are essentially querying Pino. And Presto also adds a bunch of features that we'll talk about in the rest of the talk. But yeah, overall, the key idea of the real-time analytics platform is that we want users to be able to query data in real time. But that means that the freshness of the data is very less. Like it would be like even less than 2 minutes. So that means that any event that happens right now, you would be able to query it within less than 2 minutes. So it's good for things like where you want to, let's say, monitor market health, or you want to like show some end user features where you want to show how earnings are changing based on some time parameters and stuff. So it's used for end user features. It's used for monitoring. It's used in a bunch of places actually. At this point, we have like around 100 different users. We have 400 different tables, and over the last 1 year, we have continually seen an increase in interest in real-time analytics. Like we have seen multiple orgs trying to use our platform, and we have continually seen like new use cases coming up every week in, week out. So that's really good to see, and we are having to scale with that as well. And yeah, so apart from freshness, we also like serve this in very low latency. Like our p95 is around 100, less than 100 milliseconds. Most of the queries are around 50 to 70 milliseconds, and our QPS is usually 2000 to 5000. Like it depends based on which features are being rolled out right now. Like one day it could be 2000, the next could be 3000. It's a very active system in the sense that customers are enabling new features. They try new things out. They maybe stop something and they'll try something else. So things keep on happening, and in that sense, like it's a very active platform right now. Uh, yeah, just to give a overview of like how the RTA platform resides besides the other platforms that we have. So I think you might already some of you might already know this, but we use Presto for not just real-time analytics, but also for interactive analytics. So which is done in the batch analytics platform layer that we have. Um, but yeah, I'll start from the leftmost. We have the data workflow platform towards the left. So that essentially provides tools for customers so they can write their ingestion pipelines. So the customers can write their ingestion pipeline either via code using Python, or they can also use our UI tools. So we're moving towards a no-code mechanism here where users just click on, okay, I want my data coming from this type table. I want this query to be there, and I want this to be ingested into this Pinot table. So they can just basically use the UI to convey what they want to do, and the data workflow platform takes care of orchestrating everything for them across the multiple platform layers that we have. In the middle, we have the batch analytics platform and the streaming platform. So the batch analytics platform, it's a very mature and very reliable platform. It consists of multiple services. The core storage that we use for this is HDFS. So we have a huge 100 petabyte data lake per data center. And users have like around 100,000 tables here. So these are used for BI, these are used for reporting, they are used for like all sorts of compliance, all sorts of use cases. And we also have a streaming platform which consists of Kafka. And we also have Flink, where Flink kind of acts like a data processing engine here. So let's say you have a Kafka topic with hundreds of fields and you want to ingest it into Pinot. So, but you might not be interested in all 100 fields when you're querying the data. So maybe let's say you only are looking for 10 fields. So you can use Flink to basically filter out some of the columns. You can also do some transformations on the data as it's coming in. And Flink outputs it back to Kafka. And ultimately, how these integrate with RTA platform is that we allow ingestion both from Kafka as well as the batch analytics platform. So a user can have a Kafka topic, and there will be events coming from it, maybe let's say from restaurant events or rider events. And they just let us know, okay, this is my Kafka topic. They use our data workflow platform tools to do this. And once they configure the workflow and they execute it, Pino will start ingesting the data from there. So what that means is that as soon as the event is emitted to Kafka, within like a minute or so, like it's available in Pino for querying. And for we also support ingestion in our platform from batch sources as well. So this is useful in cases where you have your data in the batch analytics platform, but you want serving latency. Like you don't want 10 seconds latency. You're not looking for 5 second latency. You want like 100 milliseconds latency. Maybe you're querying this at high QPS. So we also provide a way for users to ingest data from there. And finally, there's also a use case where people may have data from both these sources for the same table. So think of cases where the last 2 3 months you want detailed data and you want data in real time. So for that you can use a streaming platform. But for older data, maybe you show aggregated data. So because it's very hard to like keep a long range of data at very low granularity. So for older data, maybe you just want pre-aggregated data. So you can get that from the batch analytics platform, which would be a Hive table or something like that. And all of these queries, they come to the Pinot cluster via this query layer, which consists of Neutrino. Neutrino is our internal fork of Presto, which I'll talk about in the next slide. And in the Pinot cluster, we have like 3 components. These are like standard open source components: brokers, controller, servers. The Pinot cluster we usually are running it. You can assume like as it is in open source. We add like some internal tooling around it, but it's very recent. We try to keep it up to the latest version that is there in open source. And Neutrino is more like an internal fork at this point, though I'll be talking about it in the last slide as well. Yeah, so Neutrino is a Presto fork. It's optimized for real-time analytics. And the key optimizations there are, it's a single process system. So usually, as some of you might already know this, you run Presto with a coordinator and worker setup. So you have something like a cluster. You may have like 100 workers and one coordinator. And with disaggregated coordinator, you might also be able to scale up coordinators horizontally. But with Neutrino, we essentially have one JVM. One JVM is your entire Presto cluster in a way. And instead of coordinator and worker interacting over the wire, they essentially just use local memory. So they aren't making network calls to each other to transfer data. There's a single worker in this JVM, so there's no data being like shuffled between one worker and the other. So it's just one JVM that's doing all the work, and it's horizontally scalable. Like if you have like n Neutrino processes, that basically means you have n coordinator worker pairs, and all of these processes are independent. So it's in a way it's like any other microservice. Like it's stateless. All the instances are indistinguishable from each other. They're independent. They aren't interacting with each other. And in that sense, it becomes very lightweight to manage. Like, for example, like if someone from, let's say, some infra team were to look at our service, they might not be able to figure out, okay, this is actually a storage processing service or query processing service. Like, it just looks like any other service. It's very lightweight. It's very compared to the QPS it's handling, it also has like very low number of instances. Like it's optimized in that sense. So yeah, and this is how the query flow looks like. This is a very high level. I think the key thing I wanted to show here was that within Pinot, we have essentially a big cluster of itself. So we have hundreds of nodes there. And we usually use tenants to provide isolation there. So you would have a Pinot broker and Pinot server tenant for each use case. So let's say it's a Eats use case, then Eats will have their own broker tenant, they'll have their own server tenant. In Pinot, servers are where the data is stored, and broker essentially becomes a proxy point for the queries to come in. And the queries are distributed by the broker to the servers. And if we zoom in into Neutrino and to see like how a query is executing, it would look something like this. So essentially what you would have is you would have yeah. So it's essentially like any other query execution service. So it starts with like creating the AST, which is similar to how Presto works for all other connectors as well. Then you have the we have a validation framework. I'll come back to this later, but it's essentially a very small, lightweight interface that we have added so that we can perform some validation on the incoming queries and we can reject queries early on. Once you have the AST done and the validation done, we create the plan of the query. So the plan is where you figure out and all the relational algebra that is surrounding the query. Okay, you need to do a table scan, then you need to run a filter operator, then you need to run a project operator, maybe you need to run a join operator. Uh, that's where the plan. That's where Presto figures out what needs to be done with the query, and this is also the part where it also runs connector-specific optimizers. So Pino has its own optimizer, which once it kicks in, like it will figure out, okay, this is the Pino. This query is coming for Pino. So what I should do is need to figure out what's the query corresponding to the incoming query for Pino. And let's say you have a AS plan with 4 nodes. Uh, the Pino plan optimizer will try to find out what's the biggest subtree that I can push down to Pino. And once it finds out that, it will convert that subtree into a Pino query. That query would be submitted to Pino. Once you get the results back, the rest of the execution continues as well. So uh, and the way it works is like the character essentially returns Presto formatted data in Presto blocks and pages. And so for the rest of the Presto operators and execution, like Presto doesn't care like whether it's the data is coming from Pino or somewhere else. So the Pino connector takes care of running the query and returning the result in a way where the data returned is like indistinguishable from data from any other connector. Yeah, so that's essentially at a high level how things work. Let's talk about the recent work that we did over the last 6 months. To start with, let's talk about like what's a query fingerprint. So let's say we have these 2 queries at the top. You'll see that these 2 queries are kind of the same, but the only thing that's changing is the literal value in the filter comparison operator. So uh, they aren't exactly different queries in the sense that when we want to analyze queries at a large scale. So we are getting queries at 2000, 5000 QPS. So what that means is daily you would end up with 100 million plus queries. So at this high level and high volume of traffic, how do you how do you derive insights from the data? Like how do you figure out, okay, which query is expensive, which query is causing an issue with the cluster right now? Uh, unless there is a way to merge and collapse queries into something like a query category, it's very hard to figure out why is my cluster having a hard time right now. So that's where fingerprints come in. So in the example that you can see, essentially what a fingerprint is we take in a query, we get rid of all the white spaces and the comments and everything. So that is like done as part of the AST generation itself. And then we stub out all the literal values of it. So what we end up with is something like select star from airports, where airport code is equal to something. And if you think about it, like most of the traffic that comes to Neutrino and the real-time analytics platform, it's coming from backend services, and it resembles more uh, the traffic for storage systems than it resembles more for interactive analytics. What I mean by that is interactive analytics, we have end users who are actually writing the queries and trying to figure out insights from the data. So in that case, like you will have a large variation in queries. Like in one moment I might have like one filter, in the next moment I might be doing a join. So you keep on getting different queries every time. So their fingerprinting might not be as helpful, but if let's say you have a backend service, usually your query would look something like select star from airports, where airport code is equal to some interpolation value, interpolated value, and that value is interpolated at runtime based on whatever the API input might be to your backend service. So there, what you end up with is essentially thousands of instances of the same query. So that's why the fingerprinting uh, methodology is really helpful here. It's not a new idea. Like a Percona tool, for example, has it. Even GCP Cloud SQL also. Last I checked, they also like show query analytics at fingerprint level. Even internally, we have a bunch of other storage systems which use fingerprinting extensively to uh, basically derive insights from the data. And yeah, finally, once we have the fingerprint, we can create a hash out of it just so we can refer to a query. Like it becomes a very easy way to refer to one particular query. So this is one use case, which is we want to analyze traffic in real time at query level or at query fingerprint level in this case. So this in this dashboard, you can see like we have 500,000 queries coming, but we only have like 160 distinct query shapes. So we don't have a lot of distinct queries coming in, but we have a very high volume of queries coming in. So that's where the fingerprinting works really well. And you can see some of the metrics here. These are a subset of the metrics that we have, but and these are very Pinot specific metrics as well. Like Pinot has a number of documents scanned, number of entries scanned and filter, number of entries scanned, post filter metrics, which are very useful to figure out uh, can a given query be better optimized by changing the indexing strategies. Pinot has extensive indexing support. So if your query doesn't have the right indices, your query can be very expensive than it needs to be. So this UI essentially becomes a way for us to track uh, for a given Pinot tenant, what are the queries that are coming in, which ones are more expensive, and can any of them be optimized or not. So, and this is happening in real time. So this integrates with the logging platform, which integrates with Grafana. And essentially, we have a very neat way of tracking in real time which queries are coming in and which ones are most expensive. Yeah, so this is one example. Recently, we had a incident, unfortunately, where we had high CPU utilization for one of the Pinot servers in one of the tenants. So if you think about it, a given Pinot tenant would be getting traffic from maybe like 20, 30 users if it's a shared tenant. In this case, it was. So it was a shared tenant. Shared tenant is used by ad hoc users who are not really going to serve a very big use case. So we don't want to create tenants for every use case because we have a bunch of use cases. So for use cases which are relatively smaller, we have like a shared tenant. And there you could be getting traffic from 20, 30, 50 customers. And it's very hard to figure out if there is a tenant degradation going on right now, which query is causing it, or are all queries causing it? Because it could not be like just one query, maybe like multiple queries are contributing to an issue. So this is one example where using the dashboard that I showed in the previous uh, slide, we were able to quickly identify, okay, this particular query is the one that's causing an issue. And we reached out to the customers, we got it blocked, and that mitigated the issue. So this was the query that for some like for some reasons the cost of that query kept on increasing over time, and ultimately that started causing a CPU utilization issue in a Pinot server. So uh, this helped us like basically figure out the root cause of the issue in like 5 minutes. So that's really helpful when you're dealing with production scenarios and very critical scenarios as well. Yeah, coming back to the validation part that I just alluded to in the previous slides. So in this particular case, like when we had the incident, we had to reach out to the customer and ask them, okay, can you stop the query? But then we realized, okay, we don't really need to do that. Like we have a validation framework within Neutrino. It's essentially an interface where a given query comes in, and we also have the fingerprint for that query, and we take a decision based on that. Like, do we want to allow this query or not? We also perform some stats collection during this time. So maybe we want to see like how big is the query. So we also do stuff like that here. And what we have here is we have integrated this validation framework with one of our internal frameworks, which is used for dynamic config management. So by dynamic config management, I mean that a methodology for us where we can make config changes to the service without having to deploy it to the service. So you don't need to restart your service, you don't need to deploy to your service, but you can still change configs for your service. So we have integrated with that, and now we have a feature where you can specify that I want to block this query. And once you click on a few buttons within like 5 minutes or maybe like even 2 minutes, you would be your service would be blocking this query. So at this point, we can block traffic at query level. We already had capabilities to block traffic at user level, but now we can also block it at the query level. So that's something really good to have. In the previous incident, it would have helped us to like mitigate the incident very quickly because we didn't need to reach out to the customer for this. We could just do it on our end. Fingerprinting is also useful for testing, and this is something that we had an issue for a long time because Pinot is continuously evolving and new SQL features keep on coming in. So we need to make the corresponding translation changes in Pinot connector as well, because within the Presto Pinot character, we translate the input query to a Pinot query. So as Pinot is evolving, we need to evolve Neutrino as well. And with those changes, it's very hard to figure out, okay, I made a change. Is the translation still correct or not? That's a very tough question to answer because what is the definition of correct? You cannot write unit tests to check each and every test case. So that's where fingerprinting really helped us out. So we have all the queries going into a query audit log, which is essentially a Hive table. And within a test framework, we use Presto, interestingly enough, to get the unique queries from the last X days. X could be 3 or 4. And by unique, I mean we get one query per fingerprint. So even though we might have, let's say, 200, 300 million queries over a 3-day period, the number of unique queries would be around 2,000 or even less than that. And once we get these queries, we run them against production, which is running the latest master build, and we run it against staging, which is running our custom build that we're testing out. And we do a comparison of the query status, whether the query succeeded or not. If let's say the query failed in staging, but it succeeded in production, that's a red flag for us. Maybe there's something wrong with the translation. Or we also do explain plan comparison. So if the explain plan from production and staging turn out to be different, then our test framework will highlight, okay, these fingerprints have different explain plan from before. And then we can look at those fingerprints and see what's the change, like whether it's expected or not expected. If you're making a translation change, it's most likely going to change explain plan for some of the queries, but it will only change it for maybe 5 or 10 queries. So now you don't have to analyze like 100 million queries. You're only looking at 5 or 10 queries. And you can just look at them and see, okay, is the plan still correct? If it's correct, then we can proceed with the deployment. This doesn't mean that we need to stop unit testing. Obviously not. You still continue to like hold a high bar there, but this is a good tool to make sure that you don't have production regression because unit testing is not complete. There's no complete way to ensure that the translation won't be incorrect. And yeah, so yeah, that was about fingerprinting. So this is another thing that we did recently, which was a dynamic split execution timeout. So as some of you might know, Presto executes splits in something like a thread pool executor. It's not exactly a thread pool executor, but it's logically that. It's essentially a thread pool. And your new query is coming in. And once your query finishes, then it basically is out of the thread pool. So you can think of it like a container, which is like water coming in and water coming out, going out. So let's say you are serving traffic at 1,000 QPS. And for some reason, the queries start to take longer and longer. So usually the queries were finishing in 100 milliseconds, but now they're finishing in 10 seconds. And usually we have a timeout of around 10 to 15 seconds because we don't want to like just immediately fail all the queries, because in some cases people are querying a large amount of data. They might not be querying at high QPS, but they might be querying it, let's say, once an hour or something. And we don't want to fail those queries because we can serve those queries. So why fail them? And we don't want to block another use case because of it. So we usually have a very liberal timeout in that sense. But the risk with that is if you have a high QPS use case, let's say we are getting 100 QPS for one Pinot tenant, and that Pinot tenant starts to suffer, then your queries will start to stay longer in your thread pool. So what that means is that you are very likely to have the entire thread pool completely filled with queries to the point that the new queries start queuing up. And once the queue also is done, then you basically start rejecting queries. So these kind of scenarios can definitely happen at high QPS. This can also happen in Presto interactive case, but I think the edge case the use case would be a bit different there. But yeah, in our case, this was happening in some of the scenarios. So what we did was we made the timeout adaptive in the sense that we added a continuous monitoring state, and we monitor what's the current task utilization or the thread pool utilization. And if it's reasonably, if it's quite high, it's like we basically call it a red state, and we start reducing timeout in that scenario. So we continue reducing the timeout by half in every iteration. This monitoring loop runs every 1 second or 5 seconds or so, and we continue reducing timeout till the thread pool utilization goes below 90%. And once it's below 70%, then we try to increase the timeout a bit. but we don't increase it by the same amount because otherwise we might just be flipping between the two states. So we increase it by a quarter of the current value. So that way we try to find a stable state where uh, we aren't failing all the queries. At the same time, we aren't causing latency spike for the queries due to thread pool overutilization. So that's also something that has been really helpful in preventing production issues when there's a subset of queries that are having an issue. Yeah, we also did a bunch of work for query translation features. I actually would like to give a huge shout out to Christina from my team. Like she has basically delivered 80% of the features that we have used over the last 6 10 months and 1 year. And so yeah, I think this just like I mentioned, like Pinot is continuously evolving, so we need to evolve Neutrino as well for the translation, and that's where these features have really helped. A bunch of these features are not open source. I'll get to that in the last slide. And yeah, so I think one general question which might come is why not just use any other proxy? Like you can code a proxy without having to involve Presto. So why are you involving Presto here? Uh, that's a fair question, but I'll talk about the advantages here. So with having a Presto interface, we essentially have the same Presto interface that Presto for batch analytics is using. So which means we get free integration with all the upstream services and workflow integrations. So I think in the previous and original, in the first talk, Girish mentioned about some query editor where users go and they type their queries and they run it and see what the result of the query is. We got free integration for the Neutrino case because we were using Presto. So it's helpful for use cases like these. It's also helpful for customers because they don't have to keep on learning new languages every other day. Especially for cases like Pinot. So Pinot had a very big uh, query language migration recently. Like they used to have something called a Pinot query language that was effectively stopped and it's not no longer supported anymore. But we were using it for a while, I think, and even as early as 6 months ago. So we needed to migrate it. We needed to migrate from Pinot QL to Pinot SQL. But in our case, we had hundreds of users. So we would have had to reach out to every user and ask them, okay, can you change your query from PQL to SQL? Then we will have to like shepherd them throughout all the gotcha that might be there. With Neutrino, we actually did it automatically. So this was done totally automatically. No customers got pinged or paged. And yeah, we just did it within Neutrino and we were able to do it, roll it out quickly. And the biggest thing that we saved here was engineering costs because we don't want to involve engineers from 100 different teams. You should be able to do this on our own. So that it really helped us out there. And yeah, we also get a bunch of other Presto execution features. So for example, subqueries are a very common feature that users really enjoy because Pinot doesn't support subqueries completely. Pinot also doesn't have multi-stage execution support right now. But given it's the same Presto syntax that people use for Hive, they're able to write their queries without having to reach out to us. So they don't need to learn new query languages. Um, Pinot in particular has a very different language as opposed to Presto. So they don't need to learn new languages and they're able to write the queries just as they would write it in Hive. So this is one example where one of the customers, they wanted to get the top search term. So they wanted to perform a row number partition rank operator. And that's not available in Pinot, but it's available in Presto. So with this query, we essentially push down the first subquery to Pinot, get the results and post-process it in Neutrino, and then return the rank to the users. So for them, like it's a much better experience in that sense. And yeah, I'm just running a bit over time, I think. But yeah, before I close, I'd just like to mention that we are definitely looking forward to contributing many of the internal patches to open source in H2. And yeah, that's all I had for today.
Great. Well, thank you, Ankit. What an amazing presentation. Really exciting to see everything that Uber's doing with Presto and Pinot and some awesome use cases. So appreciate it. Thank you so much for a great presentation. You have a bunch of questions. Make sure to check both the chat and the Q&A tab. People, we love the questions. Keep them coming. We'll get to them as soon as the presentations are over. So I know we're running over a little bit. Without further ado, I'm going to introduce